Hello and welcome everyone. Thank you for joining yet another exciting webinar on getting started with Kubernetes. I am Jonathan on behalf of the Explorer Dev community hosting this webinar sponsored by Gapstars in collaboration with the Kubernetes Sri Lanka community and the DevOps Sri Lanka community. So big shout out to both communities and everyone joining this webinar live. We're just starting in. So first of all, if I could ask anyone joining in, if you could hear me clearly, please do type yes on the chat. Give a few seconds for that. Cool. So thank you. Just also meanwhile, let me remind you that this webinar is part of the Explorer webinar series that we've been having for the last few months. We've also last month had a session on Kubernetes, working with Kubernetes and microservices. And along with it, I think after that, few of you wrote to me back asking, could we do a session on the basics of Kubernetes? And here we are back on another session to get started on Kubernetes and to run through a step-by-step guide. So without any further ado, let me remind you also that you have the Q&A option. We're trying to take in as much questions as possible. So please do start. If you have any questions, do place them on the Q&A box. So without any further ado, let me introduce you to our presenter who needs no introduction, Nilesh Jayanandana. He's the principal software architect and certified Kubernetes administrator, also a keen writer and speaker for Kubernetes in Sri Lanka community as well. So without any further ado, let me maybe hand it over to Nilesh. Nilesh, I also have a poll that I would like to quickly check if you could just launch that for all the viewers. So I'm going to do that.
Okay.
So the question is, how familiar are you with Kubernetes, working with Kubernetes? So just to get an idea of what the audience is like for today. So let's get those questions in. Meanwhile, maybe I'll stop sharing my screen and Nilesh could take over.
Hey guys, Jonathan, are we waiting till they vote or?
No, you could continue. There's a poll going on,
Right.
but you could share your screen as well.
Okay. Okay, let me share my screen. Right, Jonathan, I get saying that host disabled attendee screen sharing.
Yeah, let me quickly sort that out. Right, should be okay.
All right. All right. Okay, can everybody see my messy desktop?
Yeah.
Oh, cool.
So Nilesh, I'm just going to stop the poll right now.
Okay.
And maybe I'll also share the results.
Yes, please.
So that you could get an idea and maybe start off with that.
Okay. Right. So I can see the poll results. I don't know whether you can see the poll results too while I'm sharing my screen. So from the looks of it, lot of 69% is at the getting started stage, and around 25% is at somewhat familiar, and only a very few are already working with Kubernetes. So I think this session would help all of you. Okay, so let me start my presentation. And then, guys, if you have any question or anything, just type it on the Q&A session, and then Jonathan, you can sort of pause me at any point and ask that question.
Sure.
and I will answer it there and there. And the end also, we will have a Q&A session. But if you have a question in the middle, just don't worry about it. Just ask, type it in, and Jonathan can post me and ask me that question, and I will answer. All
Correct.
right. Cool. Right. So, how do you present this? Right. Okay. So I think Jonathan gave me a good intro. Thank you for that. I'm a, as he said, I'm a principal software architect and a certified Kubernetes administrator on this company called Platform Cloud. And I've been working with Kubernetes for more than 3 years now. Yeah. So before we begin, so this particular webinar, this is a continuation of the webinar that I did the last time. But assuming that few of you are coming in who has not seen the previous webinar, I thought that I would just do some basics from the previous webinar. These are the slides from the previous webinar, and then we would do a live demo. So in order to do the live demo, if you want to do the live demo with me, so the first 15 minutes I would be, going through the basics of what I covered in the last webinar. So I'd expect you to sort of like set up a Kubernetes cluster yourself and have kubectl access to it, so that we can all together do the do the practical together. But it's up to you. You can always watch me doing and then try it later on. It's up to you. Okay. So before we just as an intro, quick recap. Monoliths versus microservices. So I want you to imagine an ERP system. So an ERP system, you might have an authentication service, you might have a shipping service, you might have an ordering service, you might have an employee management service, a billing service. Likewise, you might have a lot of features embedded in a monolithic in ERP system. So if this ERP was a monolithic application, all of that would be, as you can see on the left side of the screen, all of that would be a one big application bundled together, all the objects, all the classes, everything together. So as you add more and more features, this grows big, the complexity becomes very high, and also uh, it's going to pose into problems. Whereas if this was microservices, you can have auth service as a separate microservice. You can have the shipping service as a separate microservice. And you can have billing as a separate microservice, employee management as a separate microservice, and so on. You can segregate it into smaller pieces. So the advantage here on a deployment side is the monolithic architecture on the left side, where you have all the features. For an example, in this ERP, let's say that the employee management system, the employee management feature doesn't get accessed often. So it's usually when an employee wants to sort of like apply leave or do something with it, right? But say shipping service or the ordering service is something that you know that has a huge load every day. So everybody is using that service. So it needs to be scaled. So in this scenario, when it's a monolith, when you scale it, when you do horizontal scaling, you have to sort of like scale the entire application, which means like hypothetically to run all of these features in a monolith, let's say that you require around 2 GB of RAM. So in order to scale it by another one, in order to just, you only want to scale the shipping system, but you cannot scale the shipping system alone. You have to sort of like scale the entire system. So when you scale the entire system, you might have to sort of like go into 4 GB, because uh, the monolith requires 2 GB to run. So if you want to get an exact replica, another replica of the monolith, you're going to need to have another 2 GB in order to run two replicas of the monolith. Whereas on the microservice architecture, you can individually scale each and every microservice, which means that hypothetically, let's say that the shipping service only requires about 500 megabytes, then you can just scale that only. That way you can very easily uh, get sort out your efficiencies and everything. Okay. Yeah, somebody has asked, can we get this webinar for future reference? Yeah, sure. You can take this as for future reference. Right. So again, if you have any problems, just ask on the panel, and I will answer on the spot. Right. Moving on. The next concept, the quick recap we are going to do is containers. So so when we are talking about scaling and all of these things, to run these microservices, it's very easy if we have, if these microservices are bundled in as containers. So if they are containers, it's very easy for us to replicate. It's very easy for us to sort of like scale and run. So without worrying about, the application runtimes and etc., because the container takes care of it all. So as you can see in the description here, containers are a solution to the problem of how to get software run reliably when moved from one computing environment to another. So in this scenario, in a single computer, we should be able to run all of these microservices without a problem. So I think the next slide explains that this scenario. So in a monolith structure, or like the normal way, if Docker was not there, how we would go with microservices would be, for each and every microservice we have to have a dedicated VM for it. That's the best practice. So basically, for authentication service we would have one VM, for the shipping service we would have another VM, and so on. But rather with containers, because these containers run in an isolated fashion, we can sort of like have one big VM, and then in that VM we can run the auth service as a container, we can run uh, the shipping service as a container, ordering system as a container, and so on. So Docker allows us to do that, rather than we have to provision VMs for each and every service we have. You can always ask questions if you have problems, uh, questions when I explain these scenarios. Right. So another quick recap is Docker Compose versus orchestration. So there's this thing called Docker Compose. So what Docker Compose allows us to do is, in a single virtual machine, on the left side of my machine, in a single virtual machine, you can run auth service, you can run the shipping service, and then you can run all the other services as containers in a single virtual machine. So Docker Compose allows us to sort of like run a stack of applications in a single virtual machine. Whereas that's not ideal though. We need availability, we need reliability, and sometimes a single VM is not enough to host a big application that could have about 10-15 microservices. So ideally what we would do is we would have few VMs provisioned. So we can have around 2 to 3 VMs provisioned. And then what we can do is we can distribute these containers, the auth service, the auth service, the shipping service, and all of these things, we can scale individually, and also we can distribute these containers with multiple virtual machines very easily. So that is what an orchestrator would do. But Docker Compose doesn't do that. Docker Compose doesn't allow us to scale, but rather allows us to run a stack of containers in one VM, and we can manage that. But the moment we want to scale them, and then the moment we want to utilize more than one VM, Docker Compose doesn't fit in. We have to use an orchestrator. So there are few orchestrators, but as the title suggests, today we would be talking about Kubernetes. So Kavishk is asking, so you're telling when we write a compose file, it takes effect as a single VM. Yes, Kavishka. So the Docker Compose, when you run a Docker Compose is not an orchestrator, but rather Docker Compose is sort of like to run multi-container apps in a single VM. So like, for example, if you have, ideally in an MVC application, you would have a front end, you would have a back end, and you would have a database. Okay. So rather than manually, ideally that would be front end would be a container, back end would be a container, and the database would be a container. So running these three containers manually sometimes could be problematic. Rather than that, we can just define a Docker Compose file and run it easily on any VM, and then it would just run that there. But the moment you want to scale, the moment you want to do load balancing and all of those things, Docker Compose is not built for that. For that, so the other question by Tarindu Pereira. Right, so a lot of people asking questions. So yeah, I'll answer one by one. So Tarindu Pereira is asking, how do you see the difference between Docker Swarm and Kubernetes? Right. So I think I answered this on the previous webinar as well. So Docker Swarm and Kubernetes are competitors. However, what happened was when Docker Compose, Docker Swarm came into being, Kubernetes was already there and it was production tested by Google. So the Google services were already running on Kubernetes. It was previously called Borg. So while it was running, it was already production tested. Whereas when Docker Swarm came, it was very new and it was not stable. So people used Kubernetes, and a lot of then people started developing on Kubernetes. People start contributing to Kubernetes, and then adding more features to Kubernetes, and it sort of like grew into an ecosystem. So that's how people are not using Docker Swarm anymore, and then people are using Kubernetes instead. I hope that answers. That's sort of like the short answer for that question. And then, all right. How can we avoid the container service fail when relying on container service, resulting on whole system crash in this scenario? Okay, good question. So one thing is with, right. So in this scenario, what would happen is, who was this? It says anonymous attendee. So what happens is when you run, usually you have to think about availability. So you might be running one or more containers. That's one. And when you use an orchestrator, even when a container fails, or if the container exits or container crashes, container would restart. And then that's how you sort of like handle the failures and system crashes, etc. And then, if it's a monolith, how you would usually work is you can basically, in this scenario, you can basically talk to each other functions using, in-app functions. You can just do function calls. But when it's microservices, you cannot do function calls. There's this thing called gRPC. So you can do gRPC, or what you can do is you can just do HTTP REST calls to each and every app in order to communicate. So that's something that you might have to think about when you sort of move on to the microservices architecture. Right. Okay. Right. So I hope, I hope this sort of solves this. I hope you don't have any other questions and we can move on. Yeah. So new problems, as I mentioned, running thousands of containers and managing them through Docker CLI is, it's absurd. You cannot do that. That's where an orchestrator would come in. So using an orchestrator, we can very easily say, orchestrator, I need to run my Java application or my microservice. I need to scale it by 3. So the orchestrator would automatically look at the virtual machines that we have allocated to run these workloads, and it's just gonna, decide where the container should be running, and it just, keeps monitoring them. And, if one of these containers die or crash, orchestrator would know, and orchestrator would do the restart. It would automatically restart the container, or take actions to get the environment in the way that we asked it to be. So if we wanted 3 containers running of the shipping service, and if one container fails, orchestrator would know that, and orchestrator knows that we asked for 3 replicas, and then orchestrator would take necessary action to make sure that the current existing system matches the environment that we have requested. So that's how it usually works. Right. So the Kubernetes architecture, I'm sorry guys, I'm just fast forwarding all of these things because we discussed this in the previous webinar and I need time to show you guys a practical demo. uh, okay, so Kubernetes architecture. So as I mentioned earlier, when we think about Kubernetes as an orchestrator, and for Kubernetes we have to dedicate virtual machines in order for it to work. So there are a few virtual machines involved. In this scenario, we have uh, the master node. We call this the master. This is the brain of Kubernetes. This is where the Kubernetes components would be running. And then we have worker nodes in this scenario. These are the nodes that would run your workload containers. So basically how it happens is this Kubernetes master would have this API exposed, and then there's a UI for it, and then there's a CLI also for it, and we would be communicating to the Kubernetes master using the API, using either the CLI or the UI. Normally we don't use the UI much, we use the CLI. Again, as I said earlier, what would happen is that we would tell Kubernetes run my shopping service app. And then it's just gonna, using the CLI, it's gonna go to the master. Master is gonna say, all right, so Nilesh is asking me to run shopping service app. I'm just gonna have a look at all the nodes available and see which node is the best fit to run this shopping service app. And then it's gonna make that decision. And then it's just gonna hypothetically, let's say that it decides on node 2, then it just deploys the application on node 2. And then I would tell Kubernetes, the shopping service app is running great, but now I want to sort of like scale it up to 3 replicas. So Kubernetes master would acknowledge that. Then it would automatically, create 2 new copies of the shopping service app that I created, and then would run it in rest of the nodes. So it goes on like that. You will understand it when we do the demo. There's another question. Right. Okay. Yeah, so Lakshan Chatur is asking, can we add binary files and libraries to the container along with app? Yes, you can. And Nifraz Ismail is asking, so for orchestration, don't we need Docker? We need Docker, Nifraz. So I think that part was pretty clear. So what an orchestrator would do is basically manage the containers. So Docker is a container runtime. So Docker has 3 products. Docker Engine, which is the container runtime everybody uses. The second product is Docker Compose, which allows us to run multiple containers in a single VM and manage them easily. And then Docker Swarm, which is the orchestrator solution Docker provides, which we are not using, and instead we are using Kubernetes. So what Kubernetes does is, behind the scenes, when we tell Kubernetes to sort of like run my Java application, Kubernetes would be utilizing the Docker runtime or the Docker engine in whatever the node it selects, and then it's just gonna run that container using that Docker engine in whatever the node. And then Kubernetes would constantly be looking out and see if the container is healthy, whether it's running properly, and if something goes wrong, the container would restart, and then Kubernetes would, if the container crashes or anything, Kubernetes would take measurements to restart the container. So Kubernetes and Docker both are pieces of the puzzle, like pieces of the solution. Like you cannot say Docker versus Kubernetes. It has to be Kubernetes plus Docker. Okay, right. I hope I answered those questions. Yeah, Jonathan, can you complete the questions that I have answered?
Yes,
And
I'll do that.
Shantavira Siri, yes. So each node need to have Docker installed. So it's a requirement. Every node needs to have Docker or some sort of a container runtime installed, because otherwise Kubernetes cannot create containers. So you need to have a runtime installed like that. Okay. So I think I have answered all the questions. All right. Okay, now let's take a deep breath. Now we are just gonna speak a bit about the Kubernetes resources that we will be talking. So I believe rather than I do with the webinar, I'm just going to switch into draw.io. Okay. So in a Kubernetes cluster, I'm just talking about the resources in the cluster, not the cluster itself, how we would be running an application. The primary or the basic resource in Kubernetes is called a pod. Okay, so we call it a pod. So this is very hard to understand for some people. So just for now, let's imagine that if you have a Java application, a single service, that would be a container, and then it would be sort of like a pod. So we will just, for this scenario, we'll talk about a single container pod. And I think a friend of mine has just said that I'm lagging. Sorry, I think bad internet connection. Yeah, okay. So one pod is a container. That's how, like, if you want to run your Java application, this is going to be Java app, and this is a container. So a pod can have multiple containers, but for this scenario, let's just, as you're beginners, let's just say that a pod can have a single container. So in Kubernetes, container is not the primary or the smallest object. Pod is the smallest object, and we work with pods. And another thing is, pods are immutable, which means that if you change this pod, say this is running on version 1, if you change, you cannot edit this pod. Like if you want to run the version 2 of your application, you just have to create a new pod. We just have to sort of like create a new pod like this. Okay, so let's just try this out in Kubernetes. So what I'm going to do is, Docker as containers, there are official images Docker provides, which we can sort of like get ready-made applications. So if I go to Google, I can just say Docker. I'll just type Ghost. The Ghost is a simple application, so something like WordPress written in Node. So this is sort of like a bundled application. So these are, we call these official Docker images. I'm just going to copy Ghost. And if I want to run this using Kubernetes, what I need to do is, all right, I'll just have a README here. To run this very easily in Kubernetes as a pod, what I can do is I think if you have kubectl access right now, if you have Kubernetes, type it with me, kubectl run, and then I'm just going to say the name of whatever the name of the pod I want to give. I'll just say ghost pod, and then I'm just going to say -- image. The Docker image name is called Ghost. We just got it from the Docker Hub. And then I'm going to say -- restart never. And then I'm just going to say, I don't remember the port that this works with. So let me just look at the port. There you go. The Ghost port is 2368. So I'm just going to say port 2368. Okay. I'm just going to run this. I'm just going to say kubectl, the same thing. All right. So as soon as I ran it, it says that ghost pod created. So how can we list the pods? We can just type kubectl get pods, and then we should be able to sort of like look at the pods. Okay. So basically, I'm just telling you how to run a service in Kubernetes. So we are just running Ghost pod here, and it's currently at container creating state to sort of like understand or see what are the things that we can like to get more information about this pod. We can type kubectl describe pod ghost pod. Sorry. So when I ran this, I get all this information about the pod. The main thing that we have to sort of focus is up here under events. You can see that it has been scheduled. So it says that in this scenario, it has been successfully assigned for a node. This is the node name. And oh gosh, hold on. And then it says that it's currently pulling the ghost image from the Docker registry. It's going to take a little bit of time. All right, so now it has been pulled and it says successfully created, and it says created container ghost pod, started container ghost pod. Now if I do clear, and then if I do kubectl get pods again, we should be able to see ghost pod 1 out of 1 running. Okay. Just quickly look at Q&A. Right. No, I'm not. I'm not in the Kubernetes master right now. So what happened is, if you look at here, I'm just using the CLI. The CLI is installed in my machine, and the Kubernetes cluster is running in DigitalOcean. So the CLI would be talking to the Kubernetes API that runs in DigitalOcean, and it allows me to run queries with Kubernetes. I hope that answers your question. Right. So now the next thing we can do is now we can actually see the logs of this pod. So how do we look at the logs? It's very easy. Kubectl logs, and then I would give the pod name. So if I do that, you can see all of the logs in my content. Okay. And I'll be sharing this repository with you, the README file, which has all the commands, so you can sort of like try it out yourself later. Okay, that's also good. So we did a few things now. We created a pod. We described the pod to see the information about the pod, and then we looked at the logs of the pod. The next thing we need to do is, now we need to see how it works. So we sort of like need to, for now, let's port forward the pod running in the Kubernetes master into our machine. So it's sort of like a proxy scenario. We are going to port forward it. To do that, we can say kubectl port forward PO / PO stands for pod. PO is the short form. And then I'm just going to type the pod name. The pod name is ghost pod. And then I'm just going to say bind this port 2368 port into 2368. So basically bind the 2368 port of the pod into the port of 2368 of my machine. The Kubernetes cluster doesn't run on my machine, it runs on DigitalOcean. But because I have kubectl access, I can do this. Let me do this right now. There you go, it works. Let me go to Chrome, and I can do localhost 2368. There you go. I have Ghost running on my machine. Not on my machine, on the cluster. I have port forwarded it to my machine. Okay. Right. All right. So you guys are asking too many serious questions. So one person is asking, do we really need an API gateway like Zool if we use Kubernetes? Currently, it depends on your use cases. So the API gateway is a different scenario. where you have to sort of like monitor and do certain things for the incoming API requests. So yes, with Kubernetes, you might need to, it depends on your requirement. And then Kavishka is asking, if that was a web server, how do we load the files and how do we make sure make use data dumps for databases? All right, so that's sort of like a big question. Right, so let's start simple. So running databases on Kubernetes, I can very easily run a MySQL on Kubernetes. And then the way you do data dumps with MySQL is how you would normally do data dumps with MySQL. You have to sort of like hypothetically, like if you install MySQL on a virtual machine, how would you take the data dump? You would SSH into the virtual machine, you would run the SQL client, and then you would take the dump, and then you would copy that dump into a safe place. So similarly, you can do the same here. You can sort of like the pod is essentially like a VM. Okay, if you can think, just understand that pod is something like a VM. So you can SSH into a pod. So I can very easily, like if I want to SSH into ghost pod, what I can do is I can say kubectl exec-it ghost pod, and then I can just say bin sh to get into the shell. There you go. If I do lsll, you can see that I'm currently inside the ghost machine. So I can say go root. There you go. So I'm inside that. So similarly with MySQL and etc., you can do the same thing. So that is how you SSH into a pod if required. And the other question that was asked was whether how do we load files, right? So that's something interesting. So usually containers are stateless. So let's forget about MySQL for a second. There are two types of containers. One is called stateless containers and one is called stateful containers. So the stateless containers, normally you don't load files into stateless containers. You basically you would bundle your data every time, and then you would build new images. Every time you have new data, you would create a new image, and then you would just ship it to Docker and then run it as a new version of the application. Another thing is runtime configuration. So you can pass environment variables or you can mount files at runtime into containers. So that we can do. We will cover it today. And the next thing we do is basically the stateful scenario. We can bind volumes, which means that we can bind a persistent volume from a cloud disk or something like that. We can bind it to these containers, and then even though your container crashes or your pod crashes on Kubernetes, the data would get retained because it is attached to a disk now. A certain part of the pod will be attached to a disk. But I think those are advanced scenarios which we can talk in a future webinar. I mean, I only have 1 hour today. Right, so let's just keep it basic, guys. All right, so I'm just going to delete the pod kubectl. Now if I do this, if I kubectl get pods, and then I'm going to delete this pod, delete pod, ghost pod. The moment I delete it, it's gone. It doesn't restart or anything, it's just gone. So we don't want that, right? So ideally in a scenario where the pod crashes or something, we want the pod to be restarted or redone. So in a scenario like that, so usually we don't write configurations for pods when we work with Kubernetes. There's another resource called deployments. So we would be writing configurations for deployments. So in deployments, we can specify how many replicas we need. In this scenario, I have 1. So when I say replicas 1, this deployment would create exactly one pod. If I say I want 2 replicas, it's going to create exactly 2 replicas. Okay. All right. So, so that's what deployment does. And now, how do we route traffic to these pods? So there's another service here called a service, another object called a service. We can create a service here which acts as a load balancer in Kubernetes. So basically, if we want to talk to this application, we would be calling this service. We would be sending HTTP requests to this service. And then this service would be routing traffic to one of these pods. Okay. And then, all right. And then say there are runtime configurations or something that you want to mount into these pods. So that's something we call like hypothetical configuration file. We have a concept called config map in Kubernetes. So using a config map, we can mount a file or a config real time into these containers. And finally, right, this is not enough. So the last piece of the puzzle would be scaling. So we can manually scale it. We can always say replicas equals 3, and then this one would become uh, another replica. That's okay, it works. But ideally in an elastic environment, that's not what we want. We want this to be dynamic. So like we want to be like, okay, when my CPU load is high, or when there's a higher load, I want to automatically increase this to 3 replicas. And when there's low load, I want this to decrease into a standard amount like 1 replica or 2 replica. So to do that, there's another thing we have called horizontal pod auto scaler. What this would do is we can give thresholds for this. We can say, all right, so if CPU utilization of all the pods in average is more than 80%, go ahead and increase this, increase the replica set by 1. So basically I would have a min value as 1 and max as 10. So what this would basically do is this is going to have a look at all the CPU utilization of all the pods, and if it matches this one, it's going to increase it by 1 till this threshold or this condition is false. And then when we get less load, this would automatically roll back, which means that this would ideally, let's say that we have about 10 pods running now, which has reached its max, and then suddenly the load decreases and there are no load anymore. Then you can sort of like this would automatically scale down because there isn't any load. So that's what we are going to do today. Okay, so skipping ahead, I explained this stuff. I think I explained all of these things in the previous webinar. So let's just get to the demo because we don't have much time. So today we would be doing a deployment, a config map, horizontal pod autoscaler, and a service. Okay, this is the demo we are going to do. And the ones that are in gray are automatically created behind the scenes when we create these resources. As I said, when I create a deployment, automatically these gray ones get created behind the scenes. Okay, so I'll just have like quick 2 minutes to sort of like answer your queries. I believe you might have problems. Right. So the first one is, if there was a web server, how, I think that's already answered. Muhammad Masrooj, is it wrong to assign environment variables which belong to specific container via Docker Compose? No, it's not wrong. You can use Docker Compose and assign environment variables to Docker Compose, but we are talking about Kubernetes here and not Docker Compose, so it's a separate scenario. Okay, for Kubernetes we had to define them separately. How do you access a service in K8 is another problem Tarandu has. Tarandu will be doing that today. So just have a little bit of patience. We'll be doing that. Okay. Right. So assuming all of you are developers, I have this application called, let's just run it. It's a Node app. I can say app.js. If I run this, I have a demo running. I can run this on localhost 8080. And this is a very simple application. And then you can see that in this application, we have something called value from config, which I'm loading from app/config.json, which is here. And you can see here that here I have app version 1.0.0, which is 1.0.0 here as well. Okay, so it's a very simple app. So sorry, basically the code and everything is on my machine. So as a developer, the first thing you need to do is you need to write a Docker file for this. You need to containerize this. So this is a very simple Docker file I have written. So I'm just gonna build this right now. I'm just gonna say Docker build -t, and then I'm just gonna say ng93. This is my Docker handle, and then I'm just gonna say webinar demo, and then I'm just gonna give a tag also called v1, and then I'm just gonna build this. Okay, it's just gonna take a minute or so. Okay, so while this is building, I have some time for you. So do you have any questions? Any other questions? Right. Should microservices be run in one Kubernetes cluster, or should a different one be created for each service? No, Mehan. The whole point of having a Kubernetes cluster is to run multiple microservices. A Kubernetes cluster consists of multiple virtual machines. So basically, this being the master, this is a VM, and all the worker nodes are also VMs. So you need to create multiple virtual machines, and all of these together, we call it a Kubernetes cluster. And then your microservices could be running anywhere in these clusters. It's just managed by the master. So that's how it works. You don't really have a Kubernetes cluster per service, and that's sort of absurd. Okay, right. All right, so that's answered. Any other questions? Right, so if there are no other questions, I have built the image. Currently, this image resides on my machine, okay? The first thing I did, I built the image. So I can say Docker image ls. If I do Docker image ls, you can see that I have this running here. The next thing I need to do is, I'll just show you also here. The first step was build the image. And this image is in my local computer. So that doesn't help anyone, right? This image is in my local computer, and my Kubernetes cluster is in the DigitalOcean. Okay, that doesn't help anyone. So the next thing I need to do is I need to push to Docker registry. Okay, I'm just going to push this image to Docker registry. It's very easy to do. Docker push ng93 demo. All right, so it's pushing, and I'm on a dialog connection, so the dialog uploads are sometimes bit slow. So while that's pushing, let me just work on other stuff. Okay, right. So once this is pushed, then it's easy, right? Then what we need to do is, then we need to create YAML files to run the service, run the app on Kubernetes. That's the next thing we need to do. Okay. So what I'm going to do now is, while this is pushing, assuming that this is already pushed, assuming that this image is already pushed, I'm just going to create some Kubernetes YAMLs. So I'm just going to create a new folder called K8s, where I would be pushing the code. I'm just going to see what we need to do is, the first thing we need to do is define a deployment, the orange one here. So how do we define a deployment is, basically, we would run kubectl run, and then I would tell my image name. I'll say webinar, not the image name. I'm just gonna say the deployment name. I have to give a name for my deployment. I'm just gonna say kubectl run webinar demo, and I'm just gonna say dash image. My image is let's look at the image. The image is NJ93 webinar demo version 1. Okay, this is the image name. So all right, so this is the image, and I'm going to say my image runs on port 8080. So I'm just going to say dash port. I'm going to say 8080, and then I'm not going to execute this in the cluster. I just want the config YAML. And if I run this right now, this is going to run on my cluster, but I want the YAML instead. So I'm just going to say dry run, and then I can say dash o YAML in order for get the output as YAML. Okay, when I run this, I get a config created in a second. There you go. So I'm just going to say I'm going to save this into a file called deployment.yaml. Okay, right. So on the case, we can see we have created the deployment.yaml. So this is the config that is required to run a deployment of my image. Okay, so it's very easy. Just don't think much about all of these configs and all of these wordings and etc. Okay, I'll be explaining those to you. Just keep this command in mind. This is how you sort of create a deployment. If you ever want to create a deployment for whatever an image you have, this is how you would create it. Okay. All right. So now the create a deployment file, we can sort of like see the container port 8080, etc. etc. We have replicas as one. So let's try all of that. So the first thing I'm going to do is I'm just going to apply this. So first I'm just going to ETL apply -f. If I apply, let me check whether it's been pushed. Yeah, the image has been pushed. So I'm just going to say kubectl apply -f, and then I'm going to give my deployment file. Okay. Okay. So now this has been says deployment apps webinar demo created. Now I can say kubectl get. I created a deployment, not a pod. So if I do get deploy, you can see that I have something called webinar demo. And if I do kubectl get pods, you can see that there's one pod, 1 out of 1, running under get pod. So basically, in this scenario, what happened was we created a deployment called webinar demo, and then we said replicas equals 1. Because it says replicas equals 1, it just, from the config we gave, it just created a pod using the image we gave. So webinar demo image v1. This is a pod. Okay, right. That's what we have right now. You can say kubectl get deploy and pods together. So you can see that the deployment is this, and we have one pod. Now, if I want to manually scale this, I can very easily change the amount here. let's try 3. I can say kubectl apply -f deployment.yml, right? Now, if I do kubectl get pods, get deploy and pods, you can see that my deployment has updated now to be 3 out of 3, right? And then I have 3 pods running automatically created for that deployment. In this scenario, we have now 3 pods created. Okay. Is everybody clear? This is very easy, right? You just created a deployment and very easily you just edited this. You can even edit this on the go. You can just say kubectl get deploy and get the deployment names. Let's give it a sec for to work. So let's see if anybody has any other questions. Yeah, Ramke, I just showed them the Docker file. I just built it. I just wanted them to see how the flow works. So I just created a deployment, and I'm just going to do service maps and configs as well. All right, so many questions. So I'm just going to finish this up quickly, and then I'll answer the questions, okay? All right, so that's done. CTL get pods. There are 3 here. My internet is super fast, so. Pods. Right, so everything is there. So I'm just gonna all right, so let's leave it at 3, and then I'm going to do kubectl edit deploy. I can just edit deployments on the go as well. The name of the deployment is webinar demo, so I can sort of like edit it on the go as well without actually having to edit the config file. I can sort of edit it on the go as well. It's taking some time though. Maybe because my cluster is very small, and the new Kubernetes version has its weird annotations. I don't know why. All right, just edit this out to 1 again. I just make it 2. All right, so kubectl get pods. When I do get pods now, I should be having 2 pods instead of 3. There you go, 1 is terminated. And next thing I'm going to do is get pods. I can even look at CPU utilization and all of that. I can just say kubectl top pods and the CPU and memory utilization of each and every one. But keep in mind, that's not something that I would cover today. Maybe in a future session, I can sort of like show you that. So this is currently using 11 megabytes, 12 megabytes, and yeah, that's how this is working. All right. So we created a deployment. The next piece of the puzzle is we need to create a service for us to access this. So what I'm going to do is I have simple command. So kubectl expose deploy / deployment name, which is webinar demo. And then I'm going to say -- port, which is the port, and target port, which is the port of the pod that we are targeting. Basically, we are forwarding 80 into 8080. Okay, I'm just gonna say target port 8080, and then in this scenario, I'm just gonna say type equals load balancer. Okay. It's gonna take a second to get created. More than a second.
Right, I think we kind of lost Nilesh, but hold on for a sec. Let's try to get him back.
Hello. I got kicked off or something for some reason. I don't know what happened.
No
Jonathan, can
worries,
you?
Nilesh. I think you're back.
Yeah, yeah. And I changed to fiber. Right. So I'm just gonna quickly finish this up. Right. So what I was saying is that I can just get the service also out as a config. Like this was just run as uh, on the go, so I can get it out also as a config. I can just type cc.yml. Right, there you go. So this is basically the service. Not a big deal. You can see the port is 80, the target port is 88. So in the service, we are going to hit port 80, and then it's automatically, when we hit the port 80 of this service, it's automatically going to port forward into 80 and 80. Okay. And so I can just say kubectl get svc now. When I type get svc, it should have this webinar demo type load balancer. It would have a cluster IP, and then the external IP is pending. It's just gonna take a tiny little bit of time for us to get a external IP. So while that is happening, let's just focus on the config map mount. So what I'm going to do is I'm just going to mount this config.json as a config map. So what I'm going to do is I'll just say kubectl create cm, and I'm going to say the config map name would be config.json, and then I'm just going to say, sorry, I just kubectl create cm config, again, it's a config file or config JSON, whatever suits, dash dash from file. I would say I'm inside the K8s folder right now. That's why I put double dot slash, and then I would say config dot JSON, and I just say dry run dash o YAML. Okay, and then I'm just gonna say config. So when I do that under K8s, I can see my config.yml created. You can see that it's called the kind config map. And then we have under data, we have the config.json, and then we have my config file here, right? So I can very easily apply this kubectl apply -f config.yml. You can have multiple files. So if you want to like add this one also in, so what I can do is if you want to add this file also in here, I can basically type config, the name of the file is config.secret.json, and then I can give the pipe command and back, and then I can just here I can just copy this in. Okay, so this is how you do it. I can apply that to kubectl apply -f config.json. Right. Okay. So if I were to see the configs, I can say kubectl get cm, which would show me I have something called a config map now. The data is 2. Now here's the interesting part. We need to mount this config into application. So before that, let's just see kubectl get svc and whether we have the public IP. Yes, we have. So I'm just going to type this here, or like in a new tab. There you go. Our application is working and it's currently served from Kubernetes. Okay. So now let's mount the config file. So in order to mount the config file, what we need to do is we need to sort of like define a volume. So under spec, there's something called volumes, and then I have to give a name. I have to give a name for the volume. I'd say config mount, and then I can say config. There are a lot of options in Kubernetes which we don't know when it comes to this doing these configuration YAMLs and everything. It's very hard. The Kubernetes documentation is also not that great. So there's a trick that you can do. There's this thing called explain. So you can type kubectl explain, and you can sort of figure out what are the things you need to do. So in this scenario, I just want to see under volumes, what are the options I have in order for me to sort of like connect the config map that I created. So I can just say the volumes, if I look at the path of volumes, if this entire thing is the root, the first path is spec, then there's template, and then there's another spec, and then there's volumes, right? So that's how the volume path is there. So it's under the main one, spec, template, spec, and volumes. Okay, so I'm just going to say deployment dot spec dot template dot spec dot volumes. There you go. I got all the options that I have. So somewhere here it should have config map. So let me just scroll up. There you go. There's something called config map. So here, again, you can see config map is an object. So I can just type volumes.config map to see what are the options I have inside the config map. It has a simple thing. So all of these are not needed. The name is the one that they need. So I'm just going to give the name of the config map. The name of the config map we gave was config.json, right? You can say the name of the config map is config.json. All right. So in this scenario, what happened is, now when I created the pod, basically in the deployment, now I just mounted a config map to the pod. Okay, so in this pod, I have the container called webinar demo, and then there was this config map externally. And what I did was I created a volume inside the pod called config file, and then I mounted this config map into this volume. Okay, but here's the thing, this volume is still not mounted into the container. This is just mounted in the pod. It's not inside the container yet. It's inside the pod. We need to mount this now into the container also. That's the next step. We need to mount this into the container also. So in order to do that, what I need to do is under containers here, and let's type it on the name. So I can, there's this thing called volume mounts. So here I'm just going to say give the name of the volume, which is config mount. Basically, I'm just saying that this is the volume config. I want to mount this config into this container, right? And I'm just going to say path. I'm just going to say the path would be app config.json. So that's the path. And there's another thing that we need to put called subpath. So that here under subpath, we are selecting the config file. I'm just going to say in my config YAML, I'm just going to select only to mount this one and not this one. I'm just mounting this one. So in order to mount that one, I can just say subpath config.json. If I don't give a subpath, what's going to happen is it's just create a folder called config.json, and then it's going to mount two files, both config.json and config.secret.json in the scenario. Like in that scenario, all we need to do is like give like this. If we do this, it's going to mount both the files. But if I want to mount a specific file, I can just go on like this. Okay, I just want to mount a specific file here. That's why I do this. Okay, so I updated my deployment. I just say kubectl apply -f deployment.json. That was a problem. Sorry, my bad. Path. Right, there you go. It's configured. So what now I can do is I can sort of like update this. I can see the application version is 2.0, and I can sort of like kubectl apply -f config.yml. That's edited, so I can sort of like also another thing I can do is I can sort of like give resources. I can say resources this pod. I can say requests CPU. I can say this request around 200 CPUs. So something like that. You can do that. Right. Okay. I can do kubectl apply -f deployment.yml. There you go. So if I do kubectl get pods, you can see the updates are going, rolling updates are happening behind the scenes. So if I just watch this, it's just gonna get working in a bit. There you go. And now if I refresh this, notice this 1.0 here. It's just gonna change to 2.0. Okay. So that's basically how you would mount a config file. I don't think we have time for a horizontal pod autoscaler, but I can sort of, I mean, I'll just do it right now. So the auto scaling one, how would you would do is basically just type it here. kubectl expo. Hold on. I can't remember how. All right, so it should be kubectl autoscale deploy, and I would give the name of the deployment, which in the scenario is webinar demo, and then I would say --min equals 5 --max. Sorry, min equals 1, max equals, let's say, 5, and I'm going to say CPU percent equals, let's say if it's more than 70%, start increasing. Okay, and then I'm just gonna say dash dash try run dash OM. Say HPA. Right. So I have HPA also. This is how you would do auto scaling. I can just look at ctl apply dash f hpa.yml. It will just work. So to see all of your resources all at once, you can sort of like type kubectl get all. So if you type this, you can sort of like see all the resources that we created. Okay, so we created a deployment. So from that deployment, pods were created. We created a service for that deployment so that we can send traffic in. And then just now, we created an auto scaling reference to Kubernetes, which means if it's more than 70%, it's gonna sort of like increase the minimum, the number of pods, the number of replicas. So in a bit, this replicas, it's gonna scale down into one. We currently have two pods running, but in about 2 to 3 minutes, this would scale down into one because there are no load. Like there you go, it's 1% over 70% the target. So that's how it's gonna work. Okay, so that's basically it. Service. We created a deployment. We created a config and mounted it into the deployment. We added a horizontal pod to scale it. I think what you need to do is, as beginners, when I started Kubernetes, I just looked at the use case. Now this I did today is a use case. So basically how to deploy an application on Kubernetes. Just don't think much, just do this. And after you do this, and then you keep doing this, you sort of tend to understand what's the big picture here, what are the things, additional things you can do, and etc. etc. Because here's the thing, if you sort of like try to understand everything from scratch and then start doing it, you're gonna have a hard time, because that's not how it works. Just do things practically, as and when you do, you would learn more and then you would understand more. All right, so let's jump into the questions. Where there are 11 questions, I believe. I'm just gonna stop sharing. Right, so let's jump into QA. Right, okay, so QA time. Right, so the Mehan's answer I have already given. If we have a web app in a pod with replicas 2 and a service in front of it, can we access the web app using the pod's port? No, you cannot. You have to access the service port. I mean, you can port forward the pod 2, but no, you have to use the service port anonymous attendee. So that's what you need to do. How do we use AWS load balancer with multi-master K8s? Okay, Thanis, I think that's a question maybe for another webinar where I would tell you how to set up a Kubernetes cluster by yourself. That's where this would come in. Just to give a quick answer, you can set up a AWS ELB load balancer, and then you can sort of give the 3 masters. He's talking about a highly available master. So each and every Kubernetes master would be exposing the Kubernetes API through the port 6443. So ideally, how you would do normally with any load balancer, you can just port forward the 443 port of the AWS load balancer into the 6443 port of the three or more masters you have. So I believe that answers your question. I mean, feel free to have a chat with me offline. We can discuss more if you have more problems regarding that. That's a bit advanced question. Okay. Shanta Veerasiri, what's the best practice when multiple environments are there? Test, production. Right. Okay. So interesting fact. Usually I would recommend to have 2 clusters for production and development rather than put everything in the mix. But ideally, there's this concept called namespaces in Kubernetes, which we can sort of like isolate our workloads. So I would say in an ideal scenario where a company has a development environment, a QA environment, a staging environment, and a production environment, I'd say staging and production have it in one cluster, and development and QA and all the other environments, test environment, whatever, you can have it as a separate cluster or multiple clusters. It's up to you. The reason I said staging and production need to be on the same cluster, because basically the staging environment is a replication of the production cluster. So it makes sense to have both on the same cluster because the same environment. So I think, yeah, that's something I would do, but it would again depend on the policies and the practices your particular organization has. Right. If the same app is running on multiple pods, how the load balancing is handled? Priyal, yeah, I think you probably asked this question prior to what I did the service. So because there's this thing called services in Kubernetes, I just created a service. You can do that. The load balancing would be handled by that service, and that's how it works. Janet says, think that I'm going to deploy a Java application with application.properties configs. Can you give a brief explanation how to do this? Can we put application.property config? Yes, you can. Just like how did the config.json, you can put and then mount it to your container just the way I did today. So if you just look at the webinar, whatever, I'll be pushing the code to and be sharing with you. Yeah. Okay. Right. Okay, Ram. Okay. Is this Kubernetes commands and containers are case sensitive? Yes, they are case sensitive. Yeah. Yeah. To connect with Kubernetes CLI, do you need to have Docker runtime? No, you don't need to have Docker runtime installed in your own machine in order to connect to Kubernetes CLI. You don't need that. Does this orchestration scenario support database read-write replicas when scaling? Yes, you can. There are scenarios where you can very easily scale your databases up and have this master slave sort of thing. Have a look at, I don't know which databases you are thinking of. Like Postgres, there's this thing called Patroni, and it works hand in hand with Kubernetes. And there was another one for MySQL as well. I can't remember out of on top of my head. But yes, now the modern day Kubernetes, you can run your databases also on Kubernetes and scale them and scale down and have master slave scenarios and all of that. So there's a little bit of coding still involved, configuration still involved when you had to do that. It's not very straightforward, but you can definitely do that. Right. Okay, I think that was the last question. Do we have any other questions?
No, I think we're all good, Nilesh.
All right. Okay.
So, Nilesh, all good. Is there any final comments that you'd want to finish off with?
No, not necessarily. I believe this session was helpful. So, I mean, guys, starting and Kubernetes, like it's very hard to do it in 1.5 hours. But I hope you sort of understood what I did. And the webinar would be posted on YouTube, and I would be sharing the all the commands I ran and all of those things. So you can just rewatch it and then just start doing things. You don't have to understand Kubernetes to start running applications, etc. So you can sort of like learn while you do it, learn on the go. That's how I did it. Yeah, I wish you all the best, and you can always reach out to me on Facebook or LinkedIn. And if you have any questions or anything, I'll be happy to answer offline.
Thanks, Nilesh. Thanks so much for another fantastic, I think, presentation. Given the interactiveness and the questions that came in, we were able to do that. Gone also a little bit over time, so Thank you so much for doing this webinar, and also thank you for all those who have joined in the webinar. I think what we're trying to do is see as much as possible to do more interactive webinars, and also things that become more useful in terms of when it's more practical. So that's the area that we want to move forward. So if, as like last time, if you have any suggestions for topics, do write to me, Jonathan at capstars.net, or do be definitely sharing the video of this webinar. You could also get the presentation soon. So give us a couple of weeks for that. So anyway, thanks everyone for joining this webinar.
No worries.
And